Hello, everyone, and welcome to another EESSI Happy Hour session every Monday between 2 and 3 p.m. Last week, we covered the EESSI dashboard that's in the topic series of EESSI dashboard and ReFrame tests. Today, we will be focusing more on the ReFrame tests. Our colleague Sam will be presenting the session. Just a reminder before we start, the session is being recorded. So at the end of the session, we will stop the recording in case anyone feels more comfortable to share anything related with EESSI. So Sam, session is yours.
Thank you, Richard. So let's go to the first slide. So last week, we saw Caspar presenting the EESSI test suite, the dashboard, and how to run tests with the test suite. Now we will focus a little bit more on how to write a portable ReFrame test. So I will first talk a little bit about the goals of the test suite. Then I will give a small demo, and then also show the available tests that we have right now and some limitations that we have currently. So the primary goal of the test suite is to test the functionality and the performance of the software in the EESSI stack, and that in a wide range of systems in a standardized way. So this is the goal that already Caspar laid out quite clearly. I'm just going to reiterate it. So the important part is here the standardized way. So it has to be, if you run it, then it should always run in exactly the same way, so we can compare the performance between different times that we run it. But the challenge is that, of course, every system is different. So we have to find a way to make it portable, because ReFrame itself is not very portable. So it has some functionality that makes it possible to make it portable, but it's not out of the box portable. So, and the solution that we have chosen is to separate the test-specific logic from the site-specific information. So the site-specific information goes into the site configuration file, and then the test-specific information goes into the test classes. And then we have some helper class, hooks, and utility functions that will link the test with the site configuration info. Okay, so there are also some additional goals, especially for us at VOB. We already had a set of ReFrame tests locally for our cluster. And then we heard of the project within EESSI to make a portable test suite. And based on that, and then we were thinking like, okay, what shall we do? Shall we continue developing our own set of ReFrame tests, or are we going to collaborate with this new project? And of course, we chose the latter, so we're going to join forces. And but we had to make sure, of course, that it would still work in the same way that we are currently running our ReFrame tests in our cluster. So, and one condition for us was that it should also work on the local models. And this is definitely achieved, so you can definitely also run it on the local models. Another requirement for us was that it should be flexible. That means you should be able to add some command line options to select an exact partition or a model or an exact scale, some executable options, number of threads, processes, all those things should be able to be configurable in an easy way without modifying the tests themselves. Another goal is that we would try to make it possible that we run the test suite in different execution environments. So not only on HPC clusters, but also in CI, in the cloud, on your laptop. And for that, we made sure that we always have a small test variant that is small enough that it can run on your laptop. And then if you run on your laptop, it will just skip all the variants that are too big to be run because, for example, you need too much memory that is available in your laptop. And then the final goal is writing a test should be easy and fun. We should try to hide as much boilerplate as possible so you can focus on the test itself. and also make it easy to extend the test to more variants, to different ways of execution and so on. Okay, so let's start with a small demo. We're going to write a small test for the MPI for Pi package. This is a Python package that implements MPI, right? And so this test is already online. You can find it here in this link. And then, of course, you have to do some preparation here. So these are the commands that I would usually do to start developing the test. So I already did that here. So we have the MPI for Pi directory. So I copied that from the test suite so that this MPI for Pi test is also included in the test suite. So this is a test suite repo that I cloned here. And then we need, of course, also a configuration file, site configuration file, where I added 2 partitions, right? So let's have a quick look at the test itself. So here we have 2 versions of our MPI for Pi test. I have created a minimal one and a final one. So the final one should be able to be put upstream so it can be included in the test suite. And then we have the source directory, and the source directory contains our script, our Python script. So let's have a quick look at that. So it's a very simple script. Imports the MPI for Pi model. Then it parses some arguments like the number of warm-up steps here, number of iterations. And then it will set up our MPI. And then the rank is the rank of our current process. And then it will perform a reduce, so an MPI reduce on the ranks. And the operation is a sum. So it will just sum all the ranks. So for example, if you have 4 ranks, then the sum will be 0 plus 1 plus 2 plus 3. So that's 6, right? And it will also measure the time here. So there's start time and an end time. And then the total time will then be printed to standard output. And then it will also print the total number of ranks, so the results. So this line, no, it's this one, so the total, this will be used for sanity checking, to checking if the result is exactly as we want to have it. Okay. Then let's look at our minimal test. So this is a minimal test. I hope you agree with me that it's very easy. So it's very small. Everybody should be able to write something like this, right? So what we first do is import some ReFrame stuff, and then we import some EESSI specific stuff. Like this is the base class where all the magic happens. So it's called EESSI mixing. Then we import some constants, and we import the utility function find models. And the find models function will just do what it says. It will try to find models based on a string. So we have here model name equals parameter. The parameter is a function from ReFrame which will convert everything that is between the brackets into a set of variants that will run. So find models will find all the models with the string MPI for Pi in their name. So not in the model version, but in the model name itself. And for all the models that it finds, it will create a concrete test case for this. What also do we need? We need the device type. And the device type will tell us where our test will run. So in this case, we have set it to CPU. This means that it will only run on partitions that have told us like, okay, you can run CPU tests on my partition. So you can also have partitions that set GPU here, and it can also run on GPU. Maybe I should quickly show how you can set this. So if you look at the configuration file that I have here, so I have here my system is Hydra, and I have here one partition is M5. And as you can see, I have here, is it? Go down. So I have here set feature CPU. That means that CPU tests can run on this partition. Right? So I have another partition here as well. This sets feature CPU and also feature GPU. So both CPU only and GPU tests can run in this partition. Okay, let's go back. Then the next class attribute is the read-only files. This is actually optional, but we have to make it a requirement. So you have to list a number of files that you declare as read-only. Read-only meaning that they won't be changed during the test. So ReFrame can, instead of copying to the staging directory, it will just make a symlink. This is especially useful if you have very large files and you have many tests to run on many different systems to avoid excessive copying. So you can declare there. If you don't want to specify any read-only files, then just add this empty string. That's essentially the same as no read-only files. Then we define that executable, Python 3, because it's a Python script. And then we define some executable options. So this is our script, and then the two options. So we have 1000 iterations and 100 warm-up iterations. Okay. And then we also require that you set this method, required member node, which will set the minimum amount of memory required to run this test, right? So if your partition doesn't have the required memory, then this test will just be skipped. And we return here this function, but it's not really a function. And what it is, so we set 250 megabytes as a default, and then for each task, we will add 100 megabytes. And this is a typical thing that we see. We always have like one fixed amount, and then it scales linearly with the number of tasks. So if there is enough time, I can also show you how you can easily obtain these values. But let's see. Then I have a sanity function. Sanity function will just check standard output here for this string. This string says the sum of ranks. So the sum of ranks should be, if I have 4 cores, it should be 6, right? So this is calculated here. And then the final hook is a performance function that will just extract again from standard output the time that has elapsed, right? So it's a performance measure. Okay, that's it. So with that, we can just run this test. Well, we should at least be able to run this test. Let's try it. So we run ReFrame. We specify our test with the -c option. And then I will first check all the concrete test cases that will be generated based on this test. So -lc, that means, so list all the concrete test cases. Let's hope it works. Yeah, so we see that we already have a very large amount of concrete test cases generated. You can see that we have many different scales here. We also have many different models. Well, not that many. So we have 2 different ones. So the 23B and the 23A ones. And then we can also see that it can run in both the Pascal partition and also on the Zen 5 partition. So let's reduce this with some command line options. So we only have only one test case left. So for developing, that's much easier to check if there are any errors. So we will just run this again, then add some filters. So we can have a tag on the scale, for example, 4 cores. And then we can set the variable models to specify the exact model that we want to test. For example, this one. And then we can also specify the system and partition. So Hydra in my case, Zen 5. Now we obtain only one test case, so one concretized test case, which is this one. Right? Okay, let's run it. So it has already started. It is indeed running with 4 cores with this model that I specified, and on the Zen 5, and it's already finished. And it was successful. You can see it's very fast. It's running in under 1 second. Okay, now we can improve this test by adding some more attributes, but that's just to be included in the test suite. You don't really have to add it if you don't want it. So we can compare this. So just, where was it? Okay. So in my final test, what I have added is here the read-only files. I've added the Python script because, well, during the test, it will not be changed. So we can make a symlink. I can set a time limit because we know it's very fast. So we can set it to, for example, 5 minutes. We can also indicate that it's a CI test with this attribute is CI test, setting it to true. So then we can use the tag CI to only to select this test. And then we can have some additional variables. So these are ReFrame variables, which we can use for setting in the command line. And then those variables will be added here in our executable options. Okay. And then we can also run that, but it should run in exactly the same way. Okay. Let's go back to the slides. So that's for the demo for now. We currently have already 12 tests included. Some of them have both CPU and GPU variants. So it's already a quite nice set. The most recent test that was included is the Plus one, which was actually the most difficult one to implement because it does also some compilation. And with the easy test, with the easy software stack, we need to use the build-env model to be able to compile this stuff. And then we have to make sure that compatible build-env model is loaded. So this was a bit tricky, but it worked out nice in the end. And so we can easily compare all the different BLASes that you have in your systems: OpenBLAS, Bliss, UCL BLAS, MKL. Okay. And then, of course, there are some limitations. For example, currently we require that you use flat easy-build model naming scheme for your models. So in the easy stack, this is already the case, of course. But in your local stack, if you have a hierarchical model naming scheme, this will currently not work. but we are definitely open to implementing this if there's enough interest. Also, currently, it only works with NVIDIA GPUs, CUDA models, but this should be easy to implement. And we have only tested this with the Slurm scheduler, so we know that ReFrame also supports other schedulers, but we just haven't tested them, so it might work, might not work. So this is also something for the future if people are interested in it. So that was the end of my talk. I don't know how much time I still have. Oh, it's okay. I'm a bit over time, I guess.
That's fine, and thank you, Sam, for the information. Maybe I can start by asking the questions.
Sure.
Based on what criteria do you choose to make a reframe test for software? We saw that there are already reframe tests for a list of software now,
Yeah.
but how do you choose, for example, to make tests for other softwares? Based on what?
Yeah, what we choose is the software that we think is most relevant for most people. So Romax is a very popular molecular dynamics simulation package, of course. PyTorch is very popular in AI, TensorFlow, and so on. So that's what we go on to have the test for software and the libraries that have most impact, that are most used. But if you have a special interest in a specific software and you want to have it included, then be my guest. I mean, we're open for everything. So there's no limit on that.
Mhm. Any other questions for Sam? In the chat, I can't see anything there, but if anyone would like to ask. Yes, Thomas?
Yeah, so one question I was wondering about is, let's say you run a test, yeah, and then you have performance degradation. How do you figure out what's the reason for that? Can the test suite help with that?
Yeah, definitely. One thing that you can see is like, okay, when did this performance degradation happen? And then you can try to correlate this with some things that changed in your system on that day, for example. So this is one clue. Yeah, and then of course, yeah, normally, well, if the test is designed well, it should always perform exactly the same if the software itself didn't change, right?
Yeah.
So you should check then what changed. But
Would it be
there's
yeah. Would it be an idea to have some add-on tool that sort of tries to find the reason for performance degradation? So I could imagine, for example, if the performance of, I don't know, OpenFOAM goes down and also the performance for OSU microbenchmark goes down, and I see the sort of a dent at the same time, maybe then some MPI or whatnot could be the reason for this.
yeah, yeah. So you would like to have something, maybe some AI that will automatically detect and be smart enough that it can give you hints like,
Yeah.
this might be related to the network, something like that. Yeah.
Yeah.
Yeah, that might be
Mhm.
an idea. I have to think about it.
I have another question. Oh, Kenneth, please.
Yeah, I was just going to say, I think in general that would be quite tricky to do because very often, like an external influence, like a change made on
Yeah.
the system, Surf has definitely seen this where they did a system maintenance and performance tanked for, was it a particular benchmark, Caspar? Was it Ozu?
Yeah, it was also because of a new NVIDIA driver that got installed.
Mhm.
Yeah. So, I mean,
Mhm.
correlating performance changes or regressions across tests could definitely help, but only in a particular use case where you actually see, yeah, the regression popping up in multiple places.
So, I mean, to me personally, if I have to interpret the test suite results, that's the first thing I look for, right? Like if I see a regression, does that the regression happen on other systems as well? If so,
The systems.
if not, then it's system specific, then it must be something on that system that changed, right? So then it's typically an update or something that you're looking for on that particular system. If nothing changed on the system, I guess the second question is, did something change in the test suite itself, right? The test definition could have changed and that could have affected performance. And if that didn't change, then it must be the underlying software stack, right? And then you basically get to this scenario, what you were thinking about, like, okay, if I know that it's really the underlying software stack that's the problem, and I see the GROMACS performance change, then yes, it might be nice to correlate that to more low-level tests and see like, okay, did my OSU performance change? Did my BLAST performance change? Did my, I don't know, if you're running on GPUs, right? If you do a QBLAST, did that change?
Yeah.
Then you can really try to pinpoint like where in the software stack is this problem. But that's only kind of one out of the three scenarios where you can have a problem.
Yeah, okay.
Maybe I can add an additional question related to what Thomas asked. For example, if we run the OSU benchmark test, could we have some numbers that indicate what other tests should be performing in, or no?
You
Like,
mean you mean reference numbers, Richard?
yeah. So for example, we run the GROMACS and the same during the tests that are running consequently, we run the OSU benchmarks. From OSU benchmarks, can we get, for example, an estimate of what should GROMACS performance be?
Oof.
Or it's more complicated?
Yeah, it's definitely more complicated.
Okay.
Maybe I can say something like this. This was part of my PhD research 15 years ago. The answer is, in theory, yes, in practice, no. Because there's way more than just the network performance that's going to determine your GROMACS performance. There's disk, there's how well it can use the CPU, what type of GROMACS workload you're running. It gets very messy very fast. I mean, we're collecting a lot of performance data here and in a time fashion as well, but we're not collecting enough details about the workloads we're actually running. What type of workloads are there? By what are they affected? So you would need to actually characterize the workloads a bit as well before you can really know which benchmarks to look at. And even then, we would need way more low-level benchmarks than what we're currently running. Right now, we're really only running OSU. We're not running any benchmarks, say, for BLAST performance. We're not running any benchmarks for I/O performance. Yeah, Caspar is raising his finger.
Well, number one now on the list is BLAS. So we are running.
Yeah.
Yes, but that's new.
Yeah. I forgot about that one, but we would need more. Like I/O performance would matter a lot as well. And then knowing the details about the system could also have a big impact. Yeah. So it sounds like it's low-hanging fruit, but if you start looking into this, it gets very messy very fast. Yeah, Thomas.
Yeah, I had another question. So, of course, you mentioned that these tests, of course, they probably should not be very compute time demanding. Otherwise, you can't run them on all these different platforms. So I was wondering if you have put any thoughts into coverage. So it could be that maybe the CP2K test that tests some part of the code, but not the one that is relevant maybe for another user. And if there could be also sort of performance degradation just for different parts of the code.
Yeah. But so you're not limited to only small tests, huh? So you're definitely also allowed to add bigger tests, and we do have those as well. We just require that you have at least one variant that is also small. So we have, for example, for CP2K, we have different tests with different sizes. But we can definitely add also more CP2K tests because CP2K is, of course, a very big package with lots of functionality, and we only test at this moment. We only test one type of calculations, but of course, it would be nice if you can expand that further. Definitely, yes. But we need more contributors.
Mhm. Okay, thanks.
And I think what you're looking for, Thomas, is like tooling that says, if I run this workload, how much of the GROMACS or CP2K code have I actually been using?
For example. Mhm.
Yeah, I think you're looking at external tooling there. I think there may be things like this, but they're probably going to traces, and they probably require debug binaries that have lots of symbol information. I think these things exist. I don't know of any, but if you look around, you probably find something. On the other hand, it's not because they touch the same part of the code that they're running the same type of workload as well. The workload itself may still be very different. Like imagine the problem that processes matrices, whether the matrix is very dense or very spatial, could make a lot of difference in terms of performance as well. So just which code is being executed doesn't tell you everything. It's also what type of data is going through the code that may matter a lot.
Mhm. I mean, what probably could help in gathering some data on this is that you just run several tests, yeah, so that you can compare if all tests go down in performance, then sort of they are all affected by some change in the system. If you see some tests not going down and some go down, then of course, then maybe it's getting interesting to look into what could be the reason.
Yeah. What would also be interesting if we could add to the dashboard some limited deep learning that will warn us like, hey, this test suddenly went down. This doesn't seem normal. Please have a look or something.
So
we don't have
I guess
to.
that kind of links back to what Richard was asking, right? Like, do you have reference numbers of what to expect? So traditional reframe tests actually hard code reference numbers. So they basically say we know that for this test case on this system, we should achieve a certain performance. But that by definition is not a portable statement, right? Like it's very system specific. So it's one of the things we have thought about, like how would you do testing against a reference in a somewhat portable way? And it's basically the one thing that we really haven't figured out. Like there's ideas there, like we could do things as Sam says, if you look at historical results and then just make a generic statement and say like, okay, if it deviates more than two standard deviations from the mean over the past 20 results, something like that, then I want the test to fail, right? To report like this test did not meet the expected performance. That could be something, but yeah, I don't know. I mean, it's not so easy. You would really have to alter how ReFrame does comparison against the reference number. So that's pretty invasive. Another idea we had was, can we make it easy to separate out the reference numbers as well from the test, right? Like in traditional ReFrame, they're embedded in the test itself. If you could separate those out into a certain database and fill that easily, so just say, I'm going to do, I don't know, 20 runs for each test, and push the mean of all those test results into the database, and the standard deviation I'll use to set an upper and lower bound, and I'll push all of that into a certain database, and then I want to use the database for reference, right? Like then you have a database that is system specific, and you could compare every test run against that. It's another idea, but it's something we haven't gotten around to do. There is some development, I think, on the ReFrame side to make it easier to like export and aggregate performance numbers, but I'm not entirely up to speed on that.
Any other questions before I ask again? So maybe another question I have in mind. Basically, if I want to write a reframe test for a software, um, should I be aware of anything that I should take care of to have a proper visualization on the dashboard, or it's a
Good
combination
question.
for Sam and Caspar? So since the topic is dashboard and reframe tests.
Sorry, I missed it. Can
yeah.
you repeat it?
I want to write a reframe test for software X.
Uh-huh.
How could I make sure, or what should I be aware of so that I can have a proper visualization on the dashboard of what I'm trying to achieve?
So the dashboard visualizes anything that is marked in ReFrame as a performance number. So a performance number is a pretty specific thing in a ReFrame test, and anything that you mark as a performance number will be displayed in the dashboard. Does that answer the question?
Yes and no. So I do understand that yes, the dashboard will visualize whatever is marked. But what if, for example, I need a dashboard or I want to have more information, just not just a X and Y axis, maybe a third dimension thing to visualize what I'm trying to show in the test. Is that possible? I'm just theoretically asking the question.
I'm not sure I understand. Can you give an example of what you would?
It's basically multiple numbers that you want to correlate, right? So I think the answer is no. You have performance data, but it's essentially a number that comes from the test. And the dashboard just makes a standard 2D plot with the number. If you have anything more fancy, then it would also need work in the dashboard for that stuff to be shown properly.
Yeah.
But I'm trying to
now-
wrap my head around how performance can be a multidimensional thing.
Could a test produce, let's say, 3 data points at the same time? Let's say different metrics?
Yes.
Yes.
Okay.
Yes, but the dashboard will only visualize one of them at a time.
Sure.
Well, one at a time, yeah. But with the drop-down menu, you can cycle like which one do I want to show on the y-axis, basically.
But you can only do a time-based plot of how performance evolves over time. You cannot do a scatter plot where x-axis is one performance number and y is another. That would not work currently, but that will need work in the dashboard. So data-wise, you can push the data in already. Visualization-wise, more work would be needed.
Maybe just one thing, for example, if there is a test running on CPUs and GPUs, for example, on the same graph visualization, we can see the GPU performance and the CPU performance with time, and maybe that could be interesting.
Like 2 axes,
Yeah.
Yes.
left and right.
Yeah.
Right now, that it wouldn't do that, but yeah, that could make sense.
No, and the reason it doesn't is because well, I mean, if they're based on the same module, then you could do this. Right? So if there is, let's say, a CUDA enabled OSU test, and you run that both on the CPU and the GPU, then the dashboard could visualize it in one view, because then you can say like, okay, I want the well, whatever. There's one argument for OSU that basically determines is this going to be executed on CPU or GPU, right? And then that has a certain name in the ReFrame dashboard. You can say, I want to color code that, whatever. And then it will display both, and you will get a legend saying this is CPU, this is GPU. But that's only if it's really physically the same module that it's testing, right? If you have 2 modules and one of them is GPU enabled and the other is CPU enabled, currently the dashboard has no way of displaying those in the same view. Like it says these are 2. Well, is that true? Well, no, you could color code by module name, I guess. I think you can still do it, but yeah, the range of numbers might be quite different. So then it might be difficult to visualize. You only have one y-axis basically.
Any more questions? I guess we can stop the recording and see if anyone would like to share anything more.